This is practice A for section 5.5. This is the back of the worksheet. Is it possible to construct a triangle with given side lengths? If not, explain why not. 6, 10, 15. These go in order. So if you take your two smallest, 6 and 10, and add them together, is it bigger than your biggest side? 16 is bigger than 15, so does this make a triangle? Yes, it does. Your two smallest added together must be bigger than the biggest. That's the rule, if you remember. Number 14, again, they're in order. 11 plus 16, that would be the two smallest. Is that bigger than 32? 11 plus 16 is 27. Is that bigger than 32? It definitely is not. Does this make a triangle? No, it doesn't. 15 through 18, we're going to describe the possible lengths of the third side of the triangle given the lengths of the other two sides. So we're going to call our third side x. X needs to be bigger than something and less than something at the same time. This is a compound inequality. We're finding a range of values. There's no one answer to this. We're finding all of the possible lengths. And here's how you do it. You subtract the two. 12 minus 6 gives you 6. Then you add the two. 12 plus 6 gives you 18. So here's what this means. That third side needs to be bigger than 6 and at the same time less than 18. So it's going to be in between those two values. It can't be 6, it can't be 18, but it's got to be bigger than 6 and less than 18. Okay, we'll do one more. We'll do number 18. What would the third side of this triangle, what could it possibly be? Well, you subtract them and you add them. So your third side must be bigger than 6 but less than 20. Number 19, describe the possible values of x. Up here we called our third side that we didn't know x. Over here it's basically the same thing. You could call it y if you want to, but they're telling you that's the same thing as 2x plus 2. Okay, so what that means is 2x plus 2 must be bigger than 4. That's those two subtracted, and it's got to be less than these two added, 20. Now, you probably haven't solved the compound inequality in quite some time. You just solve it as two equations. Okay, so we'll subtract 2 from both sides, then divide by 2. So if I do it that way, I'll do subtract 2 from both sides. We'll get 2 is less than 2x, and then we'll divide by 2, so x needs to be bigger than 1. And at the same time, I'm going to come over here, and I'm going to solve this inequality. So I'll subtract 2 from each side, so I'll get 2x is less than 18. That way I know that x, when I divide by 2, is going to be less than 9. So x better be bigger than 1 and less than 9. If you left it like that, that's fine. Or you can just write it like this. X needs to be bigger than 1 but less than 9. Those values would work. 20 through 22, you're given a 12-inch piece of wire. You want to bend the wire to form a triangle so that the length of each side is a whole number. So your perimeter needs to be 12 basically. So you're bending this wire to make a triangle. Sketch 2 possible isosceles triangles and label each side length. Alright, so we need isosceles. What if I do 5 and 5? My third side would be 2. 5, 5, and 2 gives me 12. That makes that triangle. That's isosceles. What if I do 3 and 3? 3 and 3 gives me 6. 6 more gives me 12. That's an isosceles triangle too. Sketch a possible scalene triangle. Well, we need them all to be different, so how about 3, 4, and 5? That would work. 3, 4, 5. You should be pretty familiar with that triangle. 3, 4, 5 adds up to 12. That's also a right angle there if it's a 3, 4, 5. That's scalene because all the sides are different. List 2 combinations of segment lengths that will not produce triangles. Well, this should be easy. How about 1, 2, That gives me a total of 3. 1, 2, 9. Can you make a triangle with 1, 2, 9? No, because these two guys are too small, or this guy's too big. Those segments would never come together if you remember the circles, the arcs that we used in the lesson. So that's one possibility. I could also do 2 and 3. That makes 5. You got 7 left. 2 and 3 is 5. That's not bigger than 7. Number 23, Union Falls is 60 miles northeast of Harnedville. Titus City is 40 miles southeast of Harnedville. Is it possible that Union Falls and Titus City are less than 100 miles apart? Justify your answer. Well, you're going to need to draw a triangle here, so maybe I'll put Union Falls. Okay, so Hardenville is what they're basing everything off of. So let's say Hardenville is here. Union Falls is 60 miles northeast of that. So I'm going this way, 60 miles to get this city, Union Falls. So I'm using 2 letters there to name that point. That's probably not geometrically correct, but it means Union Falls. Also, Titus City is 40 miles southeast. So I'm going to go this way, 40 miles, and we're calling that Titus City. So again, I'm using 2 letters. Not the best thing. Is it possible that they're less than 100 miles apart? Well, here you go. That's your third side. They can't be less than 100 miles apart. Remember, if you're making the third side of the triangle, X, what could that third side be? Well, that third side could be bigger than 20, and it's also got to be less than 100. Is it possible that they are less than 100 miles apart? Yeah, definitely. They're definitely going to be less than 100 miles apart.